I end up using my software skills to help me build things that I do podcasting with. The networking work I do, particularly in the standards bodies, helps inform me and hopefully make me build better IoT products. And so although they look like separate areas, actually there's huge overlap in the way that they come together. And I think that the sort of common theme is, and it's probably a bad habit, is I like to be looking like a few years into the future and trying to be building things that are going to be relevant in a couple of years' time. And that doesn't always, I mean, one's not always right about what's coming, and even then you quite often don't get the marketing right. But what I find is that it's an easier space to make a difference, and to some extent to make money. Once the thing is mainstream, there's a lot of competition, and it's somewhat decided. And the other place where there's a lot of fun, and I'm starting to wonder whether I should spend some time there, is the other end of the process, where the thing is, the topic area is a done deal, but that actually extracting the perfect product out of it, or the perfect thing for maybe late adopters, is actually a really interesting space. And I'm starting to, as my relatives get older, I'm starting to realize that there's an interesting market in kind of almost retro products, but products that are catering to an age group who don't really want to learn 7 new things today, because they're quite happy with what they've got, but maybe it's broken and they need a replacement. So I think I haven't done much in that space, but I'm starting to think actually that's really maybe quite interesting.
I see. What kind of products could you give an example?
Well, so the main thing I'm working on as a sort of commercial activity at the moment is IoT-based products with cameras in. So we've got I work at a company called PI.PE Pipe here in Germany, and we produce software that people who make baby monitors, for example, license to do the video streaming from the baby monitor, video and audio streaming from the baby monitor to their smartphones. And we built that in a very specific way that's quite kind of, I mean, I'm English, but it's quite German in its privacy. So we use end-to-end encryption in that video stream, and we keep the keys at the edge as well. So the cloud doesn't have the keys to that conversation. So there's no risk of even if the kind of provider gets broken into and hacked, then that doesn't release the keys for the ongoing conversation, or not conversation, but the ongoing video of your baby, basically. And so that's our current activity, and I'm looking at taking that established product and migrating it into places where the camera is moving. So think about racing cars or drones or anything with a moving vehicle and a camera in it that needs live real time is interesting, because one of the things we've perfected over the last couple of years is doing that video streaming in relatively hostile networks, because quite often you find that particularly like the nursery in a house doesn't always have very good Wi-Fi. And so we needed to come up with ways of being kind of quite smart about how to use the bandwidth that was available and how to work out what bandwidth was available in order to be smart about it. And so having done that, it turns out that a lot of those lessons are actually also relevant and particularly relevant for moving vehicles, where that change happens, from minute to minute. So that's been my current focus in terms of development is that that space.
I see. Okay. Apart from the security point of view about the baby monitor application, what USP does that have apart as compared to other applications, similar applications, a lot of applications like that in the market, which
Strong
provide.
to claim.
What?
I,
1 second, there's an
One
interruption.
second.
Sorry for that.
अच्छा कलीम मैं
Should have.
ये मॉड्यूल्स देख रहा था तो सेम नेम के मॉड्यूल्स नहीं
Yes. We're back. Yeah.
so one of the things that we focused on doing was trying to make it that security, which is very much the kind of the security and privacy, very much the center of what we wanted to do.
I see.
But we wanted to make it usable. And what you too often see, and you still see, is that people regard security as an either or with ease of use. You can either have something that's easy to use, or you can have something that's secure. And that's simply not true. It's a question of designing things correctly. And so one of the things that we spend a lot of time on is to make the ability to claim ownership of an IoT device and lend it to other people really, really easy to use, such that you don't have to remember 53 passwords and I don't know. It's a very simple experience, and if you get the experience right, people understand also the security. If you sort of visually send the key over or something, then people, it's kind of like a handshake, and people have an intuitive grasp of what's happened. And I think that's the thing that we've put a lot of effort into in the baby monitor and the security camera space is
Right.
making sure that it's usable, basically.
Right. I got it. And talking about the moving object surveillance application, video surveillance kind of application, correct?
Well, no, actually. I mean, the first piece of, and this is still a prototype project, and so may not represent where we end up in the market. And that's actually something I would really like to talk about later, is how markets evolve. But this, the first place we worked on 2 projects for this, one of which was a little toy, which was a challenge that happened in Berlin here with autonomous driving of small robots around a track. And we wanted to get a live feed from that so that we could watch what it was doing and steer it to some extent, correct it. And so that was one example, and a little camera on a Raspberry Pi mounted on a couple of wheels, and that was going around the track. But then the other one, much bigger, is we have a camera mounted over the shoulder of a racing car driver, and that gives a live feed from there to the pit crew. So the pit crew can see minute by minute what the driver sees, but also in really close real time, so that over their radio link they can say to the driver, and I've heard this happen, hey, you're running out of fuel. So because they can watch things, they maybe watch the dash when the driver's watching the road. But that only works if it's real time.
Right.
And very, very close to real time. And these things move they move fast, they move, and the tracks are relatively big, so they move from cell to cell. So we're doing that at the moment. We're doing that on 4G, and I'm actually just got the parts to upgrade it to 5G. Maybe I get that done over today. We'll see. And to see so managing those transitions from cell to cell and that sort of thing without the video stuttering is actually an interesting challenge. But you're right. I mean, some of the other applications for the moving stuff, for the drones, will probably be, I don't know, mapping, or I don't want to say surveillance in the sort of classic sense, but things like, do the trees on my railway line need cutting back? And you can, to some extent, you can either have a camera mounted on the train for doing that, or you can fly a drone along the line. It kind of, that's very much up to them how they want to manage that. Maybe they don't want to mess with the train. Maybe they'd rather do it with a drone or not. So those sorts of technology changes. I mean, it is surveillance, but in that case, it's surveillance of trees rather than people.
similar question. What is different from the traditional applications which just give you a stream of video? I've also seen you have experience in WebRTC as well. Maybe you're using that technology already in this application. But what speciality or USP differentiates this application from other similar applications who just stream the video?
Well, so streaming comes in like a bunch of flavors. The sort of streaming you're doing from YouTube is obviously delayed. And then even so-called live streaming from on YouTube or Twitch or something like that is usually around 10 seconds delayed, sometimes less. And we need to be a couple of hundred milliseconds, if not less than that, in order to be useful. So we're like an order of magnitude quicker than most kind of conventional streaming technologies. And yeah, you're right, we're using WebRTC, but even within WebRTC, we're having to, we wrote the WebRTC stack that runs on the camera, so we're in control of that whole experience. But what we're having to do there is change the behavior so that it matches the use case. And a really interesting example, which I hadn't expected, is that the classic WebRTC behavior, if you lose a packet, you lose a little bit of data, what tends to happen is that the video will freeze, and then it will ask for the data again, and it'll turn up some point later. And then the video will carry on playing from the point at which it froze, but maybe twice as fast as it did until it's caught up with now. So you'll get a brief interval in which the video plays faster than real time. And that is completely unacceptable from a race car, because it looks like the driver is accelerating into a corner when they shouldn't be. And so we have to, but if you look at a video call like we're doing now, it's perfectly acceptable. In fact, from kind of point of view of somebody like a lip reader, it's probably necessary to fill in those frames. So what we want from the behavior of the video stream is different from what WebRTC was originally built for, which is person-to-person communication. And so, although we're using the same protocol, the exact kind of tuning of it and the exact behavior of it is different and aligned to the use case.
Okay. A bit technically speaking, usually this video protocol is based on UDP rather than on TCP. And UDP, I have some software background, so I can comment a bit on this. That when a frame is missed, UDP does not bother about it. It skips and carry on with the incoming stream. We can tweak that, of course, but TCP does not wants to miss any frame. It would delay or be slow or lag, but it will not miss the. So my question is, isn't that tweakable or is it not?
So there are a couple of kind of yes, absolutely. The fundamentals you've outlined are absolutely correct. TCP will basically not carry on until it's got all of the things in the right order. And so if it's lost something, it will ask for it again, and it will carry on until it's got everything stacked up in the right sequence.
So is that a problem these days?
Well, so that's completely unacceptable for in fact for most video conferencing, and the issue is that so maybe between us, I haven't looked, but between us the round trip time is probably, I don't know, 100 milliseconds or something. And so if my reception loses a packet, then and it sends it back to you, I won't get the reply for 100 milliseconds. So that means that my video has to freeze for 100 milliseconds until your reply has come back.
Right.
And that's probably, in a video conferencing context, that's probably acceptable, but in some other situations it isn't. And then the other aspect that really hugely complicates this whole area is the way that the video encoding works. And so one of the things that I think has been vastly underappreciated is how clever the encoding is of these video streams. And one of the optimizations they make is that they basically only send the differences. And so, you know, what's coming over this stream at the moment between you and me is pretty much only what's moved. And even then they do optimizations of saying, well, actually, you know, that bit of skin there, it's moved over there. And so I can take the same block that I had in the previous frame and I can just move it over a bit. So I don't need to send the actual skin tone or anything else. I can just send the block.
Correct.
And so
that's what the desktop sharing applications, these like AnyDesk or TeamViewer, they also do the similar thing.
Well, so the joy of this is that it's actually built into the hardware. Most of, like every mobile phone has a hardware implementation of typically H.264, which is a standardized video encoder. But what I was going to say was that the fact that you're only sending differences means that when you lose a difference, the next frame maybe isn't right. So you sometimes see this kind of, particularly on like a bad satellite link, you get this kind of weird blocky effect of things not being quite right, and then it settles. And that's typically because it's lost some of the intermediate data, and it's having to guess about what was moving from where to where, or what color that, you know, it said it may know that this block has moved from there to there, but it didn't know what color it was because the color information was in a frame a long time ago. And so you have this dependency graph of each image is really only the differences between it and the previous one. And that, I mean, in this call, I would have to look, but the images are only actually refreshed completely every few minutes.
Right.
So every few minutes, actually, Chrome will say, "Hey, I want a full copy of this this image as a starting point, and then I'll start making more deltas from that."
Right.
But that's really unusual, and it's a really rare exercise. And so all of that means that although what you said about UDP is correct, that you can drop a packet and it doesn't matter, in terms of the video, you'll get artifacts on the screen.
Right.
And depending on how those artifacts, where they are and what they are, how much that matters. And you may get this kind of weird stuck pixel effect that one little bit of the screen stays wrong for minutes because it hasn't been refreshed and hasn't been updated.
Right.
So that was a little bit of a kind of dive into video encoding. But it is
interesting.
It's a fascinating. I mean, I'm not enough of a mathematician to do it right, but I kind of understand at the high level, the network level, what's going on, and it is it's a huge achievement, all of that stuff.
Right. It's of interest to me because I'm also a architecture kind of a person who gets interested in the schemes and architecture of the software. Okay. So on the closing note, I would guess what I understand is if an ancestor packet or image is not correct or incomplete, the children will suffer because of that. Correct?
Yes. So there's an option that the viewing side has, which is to go and ask for that packet again, and it will turn up. And sometimes what you want to do with that is allow it to kind of fill in the dependency, but maybe not even show it because it's so late you don't want to go back that far.
True.
But you do want, you know, the piece that says, okay, well, this piece of shirt is white, and so you may be dependent on it without actually showing it. If you see what I mean? So all of this is actually quite subtle, but the joy is that was done. Most of the work in terms of the rendering is already done in the browsers, and I think that's maybe a nice segue to the standards work, which is I've been involved in the standardization of WebRTC for I don't know, 12 years or something.
Mm-hmm.
And it's been really interesting to see how that's evolved and how it's not necessarily gone the way we wanted to, or in some cases it has, and what the forces are at play in that. And then that's been a fascinating ride. I mean, overall, I think it's probably the thing I'm most proud of. And it's not a commercial success. It's made me almost no money. But on the other hand, I think, there are, whatever it is, 3 billion browsers that have WebRTC in it that's used every day, and through the pandemic was used massively. And I had a very, very small part in the standardization of that. And I think that's something, I say, of which I'm quite proud. And part of my contribution there was to make sure that it was reasonably private and reasonably secure. And so that's kind of another theme of what I'm interested in, is making sure we keep a decent level of privacy and security for people.
Were you a member of the committee in WebRTC, or what was your role?
So yeah, I contributed to the IETF group for several years, and that's pretty much the IETF standardizes the sort of low level, what goes over the wire, and so that's done at that level. And then the other piece, which I'm still contributing to at the W3C, is what do the browsers do with that wire protocol? So the packets turn up, and they need to be sent to the screen, and the screen needs to know how to manage them, and they need to be APIs to say, well, I want this bit here and whatever. And so the W3C writes those API standards. And I'm still active in that group because that's still changing, and there's quite a lot of interesting change happening in that space. So you see, I've got background blur done on this, and that's one of the kind of emerging standards about how you can do background blur efficiently in a browser.
I see. Fantastic. Coming back to the general question, from which we dive deep into this area, what one or two things would you pick as your backbone? I would say I would rephrase the question as your backbone of passion. I would phrase it like that.
Right. So I think coming back to kind of amplifying my original answer, which is I'm really interested in looking a couple of years ahead, and one of the ways I'm doing that at the moment is I do a podcast with a friend called the Distributed Future Podcast, and there we interview people who are doing technology that's going to influence the future of society, so we're explicitly looking 2 to 5 years ahead. So these are people who've kind of maybe got something in the lab, or they've written a paper about it, or they're researching it, or they've got it in very small level of production. And you go and talk to them about that. Well, I say go, you do it online, of course. But we talk to them about that, and from that you can get a sense of what the future may hold in those domains. And it's been really, I mean, we've got, I don't know, 80 or something episodes, and it's been really interesting to watch the things that people, don't want to say predicted, but things that people talked about crop up in the news. Like a couple of 18 months to 2 years later, what we've been talking about in the podcast turns up in the news as a hot ticket item. And that's always very rewarding, that like we've got it right. I say very rewarding, but my experience, being right is less satisfying than you'd hope. It's nice, but it doesn't earn you any money. There's no profit in being right, just being right, and there's no profit in knowing what the future looks like unless you do something with it. And part of the sort of standards activity is about trying to influence the future, and some of the other things that I build are kind of the more experimental things, are again trying to kind of think about what the future might be and maybe shape it. Coming back to the WebRTC activity, one of the early arguments was about like what level of encryption and what form of encryption would be optimal in a video call like this. And there was a bunch of established players who took the view that they already knew how to do video calls and that they'd already been a tremendous success because a few thousand people used them every day. And so they sort of didn't see any reason to add any encryption on top of the basic level they were doing at that point. And they said it would be very difficult to do so. And there was a draft, and I think it was Mozilla implemented did an implementation of a much more private end-to-end system, which is what we ended up with. And one of the things that happened at that point is my boss at the time at Voxeo was kind enough to let me and a couple of others implement that. So we could go to the committee, and I actually said to the group, like, 3 of us have implemented this in 6 weeks, right? So it can't be too hard for the multi-billion-dollar corporation to implement, because we've done it and here it is working. And so it's not that hard. And that, I think, I like to think that fatally undermined their argument that it was too hard to do. And as a result, we ended up with actually quite strong encryption in WebRTC that's end-to-end, that doesn't have keys stored in the middle, that's relatively immune to interception. And so it's I'm very proud of the fact that happened. I have to thank my boss at the time for like saying, yeah, okay, go do it, and putting the money up to allow that. That was you didn't have to do that. I think they did okay out of it in the long run, because they got some work from AT&T and other people out of it. So I don't think it was a bad thing from a commercial point of view. But like at the time when we did it, it wasn't obvious that there was any market for what we were doing. Because one of the things with standards is that, like, until it's been adopted, like you can't be sure that what you're doing is any use to anybody. So when there are only like 5 people who can talk over your protocol, then like it's got a lot less value than the point that we're at now, which is like, I could say 3 billion endpoints all run this, and I say through the pandemic people massively used it, and still do. We're using it now.
So what I get is you're passionate about futuristic ideas that would benefit the human race, and you're in video, you're in security. That's one side. Are you interested in non-software things as well, which are innovative and would help the community, or it's just software only?
No, I'm definitely interested in them. A lot of particularly, if you think about the podcast, we had a really fun episode where we interviewed somebody who was coming up with new ways to farm saffron. Saffron's traditionally farmed in quite warm climates, and he wanted to farm saffron in the UK. So it was a very nice little conversation about where you can grow it, what it needs, and to some extent the technological tricks you can play on the saffron to convince it to grow in places where it wouldn't necessarily grow. And so those sorts of things. And we had I'm always fascinated by like societal changes, but quite often they come back to technological innovations. So things like AI or encryption are at least part of the mix. Another example is we've had a couple of quite, in fact, several like transporty sessions. So one was a really fun interview with somebody who traveled I want to say over land, but that's not right. But like without flying, but traveled from Japan to Munich and actually ended up doing the whole round the world without flying. And it's like, it was a really interesting kind of, you know, look at trains and boats and the practicalities of it. But in the end, like even that came back to, some of it was technology. You said, well, you know, part of it is that it's perfectly possible for me to sit on a high-speed train in China with 4G or 5G and do a day's work as I'm speeding across this vast country. And he said that, you know, that allows him to take the choice to go on the ground rather than flying, whereas otherwise he would lose a day's work. And so that, you know, even though that's a transport thing, it ends up at least partially being technology related, because that enables choices. And so I think I always end up, I mean, even political stories, I end up like looking through a technological lens. Maybe that's a failing on my part, but like I always end up seeing the technology piece of the story as well.
Okay. Is there any other area unrelated to this that you have interest in, or that's the core of your passion?
I wouldn't say that it's not really, is it? Well, it's not really passion, but I think there's something very interesting about, which I sort of started to talk about in terms of being right. There's something very interesting about luck. And I think, you know, success is I think it's underestimated how much success is to do with luck. And I know that people say, you know, you make your own luck and that kind of thing. I don't believe that. I think luck happens. I think what you can do, and I read a lot and I read science fiction quite a lot, but there's an absolutely lovely sci-fi book by Ursula Le Guin called The Left Hand of Darkness, and there's a character in that who says that his luck, he knows his skill is that he knows when his luck is running, how his luck is running. So he knows when he can push his luck, when he can take a chance and he'll probably get away with it, and when to hunker down and play safe because his luck isn't running with him. And I think that is true, that there are moments when you just know that you could push this and get away with it, that if you do this, then it will probably happen. And there are other moments when you think, oh, like, this isn't going to work. Like, you know, it doesn't matter how hard I push this, and even if I'm right, you know, it's still not going to work because that's just not happening. And you, as I get older, I learn to just walk away from those situations because it's not worth anybody's pain getting into that, like, no-win situation. And I think that's a kind of life lesson, but it takes a long time to learn that. Like, you know, that there are situations where you're not going to win. It's not going to happen, and they're not rational. They're not about being right. They're not about anything you could have done differently. It's just luck and situational.
It's a deep topic and philosophical topic as well. To my point of view, it's just that success is dependent on too many factors, and a single person cannot control every factor of the world for success. I think it's limited. That's all there is, I think. Would you agree with that?
That's almost the kind of psychohistory way of looking at it, that it's a mathematical problem and possibly even a kind of, you know, quantum problem, that you can't pin down all of the details in sufficiently to predict the future. And I think maybe that's true, and maybe what we as humans call luck is actually just a manifestation of the fact that the thing is more complicated than we can get hold of, but we have somewhat of an intuitive grip of like the big factors and and we interpret that as luck rather than, I think it's maybe what we're talking about as a simplification. I'm talking about a simplification, a human scale simplification of what you're thinking of as a huge mathematical model, essentially.
Or maybe I would introduce you to God, like something like that.
Well, yes, I mean, God's the other way of looking at that. I'm not a good believer. I have sort of some residual faith, but I do think I kind of believe in luck a little more, I think.
Okay. Feel free to let me know if you want to change a topic or discuss on any other topic. Just feel free. I will just keep on going with whatever is coming in my mind anyway. Cool.
Okay. I mean, I think. Yeah, I think one.
I have a huge list of things to discuss, by the way, but you can change the topic.
So go for it.
Yeah.
Go. I mean, bring up another one, and we'll see. I think I've probably said most of what I want to say, but ask away, and we'll see how we go with it.
Before we close this WebRTC topic and video topic and security topic, one question: what challenges did you face, and how did you solve those challenges, to the extent you want to share with the public?
Well, I think what's maybe interesting is to talk about the unexpected challenges. I mean, there are some obvious challenges, in terms of we were building a piece of software that was quite complicated, and so we but I had a lot of help. A lot of friends gave me good advice, and so we built relatively complicated stack. Some of it was from open source, and some of it isn't, but without a huge amount of work. And again, not without a huge amount of work, but like in a time scale that was manageable.
Okay.
And I think that is interesting, and I think in doing that, we sort of signaled that it was possible, and now there are 3 or 4 other people doing, or more actually, doing similar things. So I think that's kind of interesting. But the unexpected challenge,
specific
I
ones,
think, is the business one, but it's even more. It's trying to understand. The thing that we found, it seemed to me completely obvious that people would want more secure and more private IoT devices. And it turns out that's not true, or rather they're not prepared to pay for it. And they're only prepared to pay in narrow niches. So people are very, very conscious of the privacy and security of their children. And so hence the baby monitor is a good example of like places where this goes. But the thing that we hadn't realized, or I hadn't realized, is that you can only get into an IoT device at a particular phase in its development. Like, we have to meet and talk to the people who are designing an IoT device before they've ordered the parts. Because by the time they've ordered the manufacturing, they've probably made some decisions which will make it very about where the processing will be done typically. And they've said, oh, well, we'll do this in the cloud. At which point it stops being, maybe they don't have a local key store on the device, or maybe they've decided to not pay for the encryption chip, or, so there's a sort of, they've made a decision in terms of the bill of materials, at which point it's very difficult for our software to run on that device. And then, having made that decision, if we get lucky and the device is capable of running our software, and we get our software in there, there's then a long lead time between when that's made and when it gets out in public, and then when there's a quantity of them out there. And so what I sort of, because I'd always written pure software before, I had expected quite a fast round trip time, intuitively, not really thinking about it. I didn't do the kind of business planning correctly on that. But what I hadn't figured in was this sort of narrowness of the window you've got to get in there. And then the length of time of that curve of adoption is longer than I'd expected. So I think from a business challenge, I think that's probably the biggest one, is understanding that arc and timing your approaches correctly to it, and making sure you're visible at the right moment in a product's life cycle.
Any challenge related to software only?
Yeah, I mean, it's a moving. I think that this is both good and a bad thing, but typically the far end of our, so like, you know, these baby monitors. I don't know if you, yeah, there you go.
Yeah.
The far end of them is a consumer device. The other thing, like, that's sitting there and people pointed at the baby, but then to watch the baby, they use they use a cell phone, and the software on cell phones changes really fast, and all of the rules change really fast, and they change to accommodate a bunch of kind of external threats that are actually irrelevant, I say threats, but situations that are largely irrelevant to our use case. So an example of that would be that you can't have, if you go to a page in a browser, you can't have that page immediately open a video pane and start playing video. So I can't build my software in such a way that you can just browse and connect immediately to this. There has to be, the user has to make a click, otherwise no audio will play. And that's because there was a whole phase about, I don't know, 8 years ago or something, when there were all of these banner ads that would just blare stuff at you on all of the websites. And so the browser manufacturers had to change the behavior such that if you wanted your video to play by default, it would have to be silent. And that's completely unacceptable for a baby monitor. You know, you don't want a silent baby monitor. That's not the point. And so we spend quite a lot of time avoiding these new restrictions, or they're not all restrictions, but like working around the capabilities of the browser. And that's another reason why being on the W3C working group is useful, because I kind of I see these things coming, and I can sometimes maybe influence the path of them. But mostly they are they're necessary defenses against either privacy invasion or hacking or just really, really annoying adverts. And so I understand where they come from, but in terms of the kind of challenge, that continual change from, I think it's every 6 weeks, 5 weeks, Chrome updates, I have to look to see what's changed, what's going to break. And I have a few weeks to fix it before that gets to general release. And so that's a regular, constant thing I had to be aware of. And because what we're doing is not mainstream, it isn't always like, so if you're building something that's very like Google Meet, then you're going to have exactly the same problems that Google do. And so Google will at least have provided a workaround for themselves, if nothing else. Whereas because we are doing something that is somewhat different and using the same technology in a different way, there isn't always, like, there isn't always a workaround for it. I mean, there always is in the end, but sometimes you have to kind of dig really hard to find it, and sometimes the result is a little unsatisfactory because of that. But you know, I mean, it's rare that becomes a real problem. I mean, I think you know, you do see, so a lot of the apps I end up building have like you'll have to click this button to start, which is mildly irritating. It would be nice if you could just drop straight into it, but you know, people accept it, and it's not a huge challenge.
Would you like to share anything specific and technical solution that you came out for a challenge or problem regarding the video time and efficiency and security, encryption, anything device support? Any specific thing you want to share?
Well, so I think, I mean, it's worth contextualizing this in that, I mean, that what we're doing is absolutely based on standards. So we haven't invented like a new wire protocol, and we use the browser. So like we're constrained to stay within that space. But I think the two things that we've done that are really interesting, one of which is that we've taken a huge chunk of code that expects to run in a browser, typically on a laptop or a high-powered phone, and we've implemented the same specification such that it'll run on a Raspberry Pi Zero. So we've trimmed out a lot of the, I was going to say unnecessary, it's not actually, well, it's unnecessary in our context. So because we know what hardware we're running on, we don't have to have the multiple layers of hardware adaptation that, you know, Chrome doesn't know what your laptop's got until it switches on. So it has to kind of check and then make sure it could use this video card or that one and this audio or that one and like all the possible options. So it has a lot of like optional code in there and a lot of complexity managing those options. Whereas, you know, if I know that this is going to sit on a Raspberry Pi, then I know exactly what's going to be available. And so I can kind of remove all of that optionality and just focus on narrowly on that. So I think that's an innovative, I mean, it's sort of not innovative, but it's important. And then the other thing that is genuinely innovative is the way that we do key exchange. I mean, so much so that we've got a patent on the way that we do the key exchange for these devices. We have this concept that, you know, the first person to switch on a device is probably the owner. And then the device will, if it's got a screen, it'll show you a QR code. And if you scan that, then you're claiming ownership of it. And we do that in a particular way, the key management for that in a particular way, which means that we didn't have to trust the cloud service that you were going through for these two devices to meet up. The two devices only have to trust each other. And that's, and then we've extended that so that you can, if you are the owner of a device, you can then lend it to somebody else, again, by showing them a QR code or some other means. We don't actually, it doesn't have to be a QR code, but it's visually it's clearer. And that easy trust relationship, like I say, backed up by the patent, is something that is innovative. And I think we're still too wedded to, we're getting away now slowly from passwords being the only thing and having to remember like 10,000 passwords or whatever the number is, you know.
Right.
We're getting to the point where people realize that's simply not possible. And that we need to build passwordless systems. Unfortunately, a lot of them are quite centralized and you know, single sign-on type devices. You end up like telling Google everything about your life, or Microsoft, or whoever it is who holds your single sign-on credentials. And that, you know, in a corporate situation, that's fine because, you know, you expect the company to know everything about your working life. But outside that, it's really not that acceptable. And so, like, I think what we've done with this in terms of like decentralizing the trust, kind of it's sort of almost Web3-ish, but not quite. I mean, it's Web3 aspirations, but not technology.
Okay. Blockchain?
Well, exactly not the blockchain. So, I mean, again, the blockchain is sort of, it's decentralized centralization. Like, you know, the blockchain is one huge blockchain. Okay, there are multiple copies of it, but it's essentially one data structure. Whereas our view is that, like, basically each device can be responsible for its own security. And so, you know, this device has nobody else's keys in it other than its own and its owner and the people who are allowed to use it. And there's no need for anybody else to know what those keys are, and there's no need for it to have anybody else's keys. So it's a kind of much more of an island mentality.
Like
now, obviously,
the USB sticks having the encryption keys, is that similar?
Similar kind of idea that that's localized to a device, and the device knows that.
Okay.
But it's a kind of what it does practically for people is that it means that they're not. If the central thing gets hacked, then everybody loses.
Right.
Whereas even if you hack one of these monitors, right, okay, you get access to that monitor. Like, so if I break into it and I put some wires in it and I hack it, all right, so I can get the video feed from it. Well, to be honest, if I can break into it, then I could put another camera there anyway, probably. So, like, there's a risk, but it's not a huge risk.
Got it.
And all of the other cameras are unaffected by that. And so you've not got this kind of mass honeypot effect that a lot of the cloud services are now starting to suffer from.
Got it.
So, and that's kind of almost more, you were asking whether I was passionate about things that weren't software. Well, that's not software, that's politics.
Right. Got it. Last question, a specific question before we close the topic that is running in my mind constantly. How do you, if you want to share, how did you solve the ancestor and child problem in video streaming, where the child depends on the ancestor image, and the ancestor image was not sent correctly, and now the child has to either suffer and not show good results, or get the ancestor back again, spend time at that spot, and get the ancestor image, create the chain again, and then render, which will have side effects, I guess. Anything?
Right. No, that's a really good question, and well described. And basically, the answer is that we take two, and we don't make this decision entirely ourselves. So because typically this is the endpoint is a browser. So to some extent, this is decided by Chrome, but we can steer that, or Safari or whatever. But to some extent, we can steer that decision. And the two things that can happen, one of which is that you can ask for enough data to complete the old ancestor image. So you can send a message back saying, I really need this packet. And the originating device will send that packet back. And all right, it will be late. It will be massively late sometimes. And then you have a decision about whether you play those intermediate frames or whether you just fix the current one. But you can get into a situation where, like, and this is often, or not often, but this can happen, say, when you switch cells on a cell phone service. You drive like under a bridge and you come out the other side, and then you're switched to a different cell tower. And you're going to lose traffic for a quarter of a second, half a second, and that's a lot of video. What tends to happen then, and we can steer this and tune when this happens, is Chrome just says, I give up. Like the decoder says, I have no idea what's happening. Like I don't have enough information to put any sort of picture together that's anywhere near right. And at which point it asks for a complete new, fresh frame from the beginning. So it's like starting afresh. And then we send that along. And one of the things that we've done with that is to say, the moment we receive that request, we know that everything else is irrelevant. So we clear the pipeline, we clear the buffers, we clear everything else out, so that there's nothing in front of that frame. And we generate it then and there,
right,
and send it as quickly as we can. And so at that point, you start afresh. And what you'll get visually is you'll get a discontinuity. But as I said, particularly in the case of the racing cars, it's better to have a discontinuity, particularly if you've just driven under a bridge. It's not a surprise for anybody, really. But it's better to do that than for them to appear to be accelerating. and so we
Right.
sort of try to tweak that. But like I say, the protocol allows us to ask for a new ancestor frame, and then part of the challenge that I have on a relatively daily basis is convincing the camera to generate that in an efficient way, because these things are basically all done in hardware. So you have to find like the right hardware tweak to say, hey, generate me a new full frame and send it now.
Right.
But just to kind of finish that topic off, it's worth mentioning that there's a huge penalty for doing that. These full frames are typically 10, 20 times bigger than the delta frames. So, you're paying a big bandwidth price for sending a full frame. So you want to try and avoid it if you can.
Right.
But on the other hand, you don't want to irritate the user. So it's a really interesting trade-off there.
By the way, do you think this challenge will be there anyway in few years, because the internet speed is increasing, like 5G, 6G, satellite? What if I say that these problems will not even exist in few years? The bandwidth issue, everything will be fast anyway, even if you're not so optimized in terms of bandwidth, it will not matter anyway. Would you agree with that?
I think in some narrow situations that's going to be true, but my experience with, like, there are some physics that kick in. Like, you drive under a bridge, your signal is going to be under a reinforced steel concrete bridge. You're probably going to get a bad signal. And so however subtle you are, unless somebody actually goes in and puts a radio mast under that bridge just for the second and a half that you're driving through it or whatever, you're going to get those short cutouts anyway.
Right. But apart from these rare circumstances, what else?
I think if you look at the situation, like, more typical video conferencing and not moving objects, to some extent you're right, but I think a lot of that bandwidth is going to get consumed by other things. And in terms of like 4K video, or if you look at the metaverse type stuff, that's like 3D cameras. So and actually the metaverse, the latency thing is apparently huge. Amusingly there's an unofficial measure of quality of virtual reality software, which is first time to vomiting. Like, so, people genuinely feel sick using bad. If you've not got the latency and the user interaction correct on a VR experience, then people literally feel sick. And the time, the better you make it, the lower the latency and the more interactive it is, the longer that time is. But it's still not very long. And then I think the other piece of physics you got to bear in mind is that, like, it's still the speed of light. So, I actually don't know where you are, but I'm guessing that the speed of light between us is probably not going to reduce the round trip time between us to less than, I don't know, 100 milliseconds or something. Like, there's some physical constants. I mean, the financial traders actually spend a lot of money straightening out the fiber links between financial hubs. So, like, they will buy a piece of land which allows them to trim a few yards off a fiber link, because that kind of nanosecond or whatever it is that it saves is worth it. Because the speed of light is the speed of light, and there's, like, we don't yet know any way of avoiding that.
Okay. I mean, we have theories like black holes or wormholes, but that's a different thing
Yeah, I'm looking forward to having a black hole in my phone. That'll be fun.
Theories again, yeah. Any programming language, stack, technology that you like, you're more interested in. We might not go deep into it, but anything you want to share. And I was also thinking why. It's a lame question. I'm not an expert in WebRTC. I know that, but why use WebRTC anyway? I shouldn't be asking this question, but if I was a layman, uneducated in this topic, a normal person would ask, why use WebRTC anyway, where you have such problems, you are dependent on the browser, you cannot do anything outside the browser, then you have to deal the things that you stated, like the application in a mobile, you have to tap on it, it does not runs automatically, all these things and a whole host of list of problems that come with any solution actually, whatever solution you choose. But seems like when the browsers give facility, they're universal as well, but they also introduce problems as well. One of that, you stated that you have to tap on the screen, you cannot do it automatically. That's
Yeah, so I think there's two ways to look at that. One of which is that, and to be fair, what we tend to see is that users who are using the same device day in, day out will install an app on their smartphone, and the app will run the same WebRTC code base,
correct.
but probably without those restrictions.
But
so,
but wouldn't the
you
app
know,
would have a browser inside that? Usually that's what people would
well,
do.
Well, no, because Google
Okay.
open sourced the underlying implementation as well, and so you can take that. It's an enormous library, but you can take that library and you can run it in a native app on a smartphone, both on Android and iOS, and so you avoid a lot of those things. You still have to ask for microphone permission, but you can do that when you install the app.
Okay.
And so there's still a permission problem,
Got it.
but it's moved.
Hmm.
And I think people are installing a baby monitor app like expect to have moving video and audio and whatever. So there's like, um, I think it's expected. But what you lose then is the spontaneity. What you lose is the ability, say, for me to send, like in fact, like you did with me, you sent me a link to this conference, and I just clicked on it in a browser. You didn't ask me which browser I was going to use. We didn't need to know any of that. And so that universality, the ability to just send a link to, one of, I don't know what the number is, 3 billion people, and have a reasonable assurance that it will work,
Right.
is actually really, I think it's a democratizing thing.
Right.
And to be fair, Google have put an absolutely massive amount of effort into making WebRTC work well in quite a wide variety of circumstances in terms of like networks and computers and, a wide variety of device capabilities and therefore, like I said, democratizing the product. So I think that's one that's one really big reason for doing it, is that it's like it is a democratic process, and I don't have to ask, like, do you have a Dell blah de blah with this particular feature and 7 other questions? Like I can just say, like, if you've got a browser and it's less than 6 years old, it'll work pretty much. So that's one thing. So I think that's kind of quite a big issue that you can do that. And then the other thing is that we, in terms of from our customers' point of view, the fact that we haven't invented a whole new technology means that they aren't exposed to the same set of risks. Like, because we're using a standard, well-studied technology, people understand what the hacking risks are. Like, there are people who understand the protocol and can tell you what's wrong with it and whether you've done it right. And so, building on an established standard is a huge comfort for our customers, that they know And the worst case is like if we folded up and stopped working, like there are a bunch of other people who could take the WebRTC piece and rework it to use their implementation or whatever. So it's like it's not like we are
alone in this.
And there's a cryptographers absolutely hate the idea that you've invented your own crypto without any like third-party input. If you start inventing cryptographic processes on your own in your bedroom, like the cryptographers see that as a huge warning that it's probably got a hole in it that you haven't thought of. So I think there's a really big incentive from that point of view as well.
And you would think any alternative than WebRTC, nothing better than WebRTC? No point in that.
Not yet.
Okay.
You know, I participate in standards committees that are looking at alternatives and subsequent versions and other technologies. And you know, I contribute to them, and hopefully there will be a better one that solves some of these problems or is more efficient or whatever. You know, technology, continual process of improvement, and I'm not. I wouldn't want to stop that, but at the moment, and I suppose this comes back to the first thing I said, when in the standards committees, we made some fairly forward-looking decisions, particularly around encryption and around the video technologies that we used, and that has meant that it's still got a few years life in it before it's out of date. Like that ability to be a bit forward-looking gives you a bigger runway, effectively, to run the software forward or the technology forward, into the future.
Right. Any stack programming language or stack?
Oh yeah. You asked about programming languages. I'm still quite a fan of Java. Java has evolved over the decades. I mean, I wrote something in Java when it was still in beta in, I don't know, 1997 or something. And it's evolved. It's still the same basic principles. And then, to be fair, it was originally aimed at IoT devices. That's not where it emerged and where it was successful, but the original design was for set-top boxes and other IoT devices. And so it's kind of nice to be using it again on IoT devices. And it has a really nice set of principles around memory safety and thread safety and type safety. And so it's still, for all that it's quite an old language, it's quite safe environment for programming in, which I think is important. And I particularly, if the rest of the product is around security, I think it's necessary to make those decisions. And so I still like Java, and I still use it. We still use it on the main product. I'm learning Go, Golang. I think there's some very interesting use cases for Golang, and more, I think, on the server side than necessarily on the small device side. But I don't find it, as a language, I don't find it a huge step forward from Java. I don't think there's anything in it that is a huge win. I did start to learn Scala, but I found that there were too many choices. There isn't what's nice about Golang is that it's basically a single way that you should do things, and it's quite prescriptive in, there's a single layout, there's pretty much a single style for how you do stuff, which makes it relatively easy to learn, and it makes it easy to co-work with other people on projects, because a lot of that stuff is enforced. Scala is got a lot of really, really nice features. I love some of the ideas in there, but for any given problem, there are typically 5 or 6 different solutions and styles that are valid. And unless you're very, which makes it really hard to learn because all of the examples disagree with each other. And then the other thing is that it makes it very hard to work as a team because first thing you have to do is establish which of these 6 or 7 styles, like you have to write a massive style guide of like our Scala looks like this. And then you have to retrain people who have done Scala projects that weren't like that. And so I felt that it undermined its promise. Very occasionally, I still write C. I mean, I wrote C in the early 80s. I wrote a lot of C in the early 80s and into the 90s. But I just think that it's too easy to make really serious mistakes in C that you won't catch up or won't catch up with you until somebody hacks it. And I have somewhat the same feeling about some of the other languages that are sort of filling in the niches there that really aren't secure yet.
Rust is emerging. Rust language.
I haven't learned Rust yet. I should maybe. I find I don't warm to what I've understood is the memory management model. I'm somewhat ignorant on it, but I do like the idea that specifically in Java, that Java manages the memory for you. Like the assumption is that it knows what it's doing and it will track memory and it will free it and release it and stop it from being doubly used and all of those things.
Garbage collection.
And as you say, do the garbage collection. Whereas Rust is a sort of more ownership model, I think. And I think there are use cases where it makes sense and maybe I should learn it, but I haven't yet. And I don't feel I desperately want to.
Right, got it. Moving to the next, I have like 2 main topics further. Could we take a 30 seconds break or 1 minute?
Yeah, sounds good. In fact, give me a couple of minutes. I will make myself another cup of coffee if that's all right.
Sure.
Okay, back in a tick.